Welcome back to Science to Sleep By. Tonight, we travel beyond our sun and toward the nearest stellar neighborhood to Earth. For generations, astronomers have gazed toward Alpha Centauri, wondering whether planets might circle those distant suns and whether life could someday exist there. And now, with the incredible power of NASA's James Webb Space Telescope, scientists are examining this nearby system with unprecedented detail. What they are discovering is not frightening in the traditional sense, but perhaps something even more profound. The universe, once again, is reminding us that reality can be stranger, larger, and more mysterious than we ever imagined. So dim the lights, relax, and join me as we journey nearly 4.5 light years from Earth to explore one of the most fascinating regions in our cosmic neighborhood. For most Americans, Alpha Centauri may sound like something from science fiction, but to astronomers, it represents the next frontier. Located about 4.37 light years away, the Alpha Centauri system consists of three stars. The two brightest members, Alpha Centauri A and Alpha Centauri B, orbit each other in celestial dance that has continued for billions of years. A third and smaller star, Proxima Centauri, quietly circles far away from its larger companions. Scientists have studied this system for centuries because it is our closest stellar neighbor. Yet, despite its proximity, many questions have remained unanswered. Could planets survive within such a complex environment? Could conditions suitable for life exist there? And perhaps most importantly, what secrets have remained hidden simply because our instruments were not powerful enough to reveal them? The James Webb Space Telescope, launched to observe the universe with extraordinary sensitivity, is beginning to change that picture. By studying infrared light invisible to human eyes, Webb allows researchers to peer through cosmic dust and examine structures and temperatures that previous telescopes could only hint at. What scientists are finding is not evidence of alien civilizations or cosmic disasters. Instead, they are discovering how dynamic and complicated nearby star systems truly are. The disturbing aspect, according to some astronomers, is not that Alpha Centauri is dangerous, but that nature appears far more complex than our earlier assumptions suggested. Every answer uncovered by Webb seems to generate new questions, reminding humanity that even our nearest cosmic neighbors remain largely unexplored territories. One of the reasons scientists are so fascinated by Alpha Centauri is because it offers an opportunity unlike any other. Most stars studied by astronomers are dozens, hundreds, or even thousands of light years away. Alpha Centauri, however, is practically next door on cosmic scale. Because of that closeness, researchers hope it may eventually become humanity's first interstellar destination. Yet, Webb's observations have revealed that this neighboring system may be far less simple than once imagined. Alpha Centauri A and B influence each other through gravity, creating changing environments that affect any planets that might orbit them. These stars produce stellar winds and radiation patterns that can impact planetary atmospheres over immense periods of time. Meanwhile, Proxima Centauri, the smallest member of the family, has shown itself to be remarkably active. Previous studies revealed powerful stellar flares capable of releasing tremendous amounts of energy. Such activity raises concerns about whether nearby worlds could maintain stable atmospheres or support conditions favorable to life. Scientists examining these observations understand that habitability involves much more than simply locating a planet in the so called Goldilocks zone. Magnetic fields, atmospheric chemistry, radiation exposure, and geological processes all play essential roles. Webb's remarkable sensitivity is helping researchers refine their models and better understand these complicated interactions. What some describe as disturbing is the realization that planets that initially appear promising may face challenges far beyond what earlier theories predicted. Nature rarely follows simple rules. Instead, it represents layers of complexity that force scientists to rethink assumptions and embrace uncertainty. That process, though humbling, represents the very heart of scientific discovery. Perhaps the most exciting aspect of Webb's observations involves the search for exoplanets. For decades, astronomers have suspected that planets exist around the stars of Alpha Centauri. In fact, Proxima Centauri is already known to host at least one intriguing world called Proxima b. This planet lies within a region where temperatures could potentially allow liquid water to exist, making it one of the most discussed exoplanets ever discovered. Yet, habitability is not granted. Webb's instruments are designed to investigate atmospheres, thermal signatures, and subtle clues that may reveal the chemical makeup of distant worlds. Researchers are especially interested in molecules associated with water vapor, carbon dioxide, methane, and other compounds that can provide insight into planetary environments. However, the closer scientists look, the more they recognize how difficult the search truly is. A planet may reside in the right location and still be bombarded by intense radiation. It may possess water yet lack a protective atmosphere. It may once have been habitable but later transformed into a barren landscape. This growing awareness can seem unsettling because it highlights how fragile favorable conditions might actually be. Earth itself appears increasingly precious when viewed against the backdrop of these discoveries. According to scientists, our planet benefits from a remarkable combination of factors that together support life. Webb's observations remind us that such combinations may be rarer than once assumed. Far from diminishing hope, these findings deepen appreciation for our own world and encourage continued exploration. As humanity peers into neighboring star systems, we are learning not only about distant planets but also about extraordinary circumstances that make our own existence possible. Long before the launch of James Webb Space Telescope, astronomers regarded Alpha Centauri as one of the most important destinations in the night sky. Situated approximately 4.37 light years away, this neighboring star system has occupied a special place in scientific thought because of its relative closeness to Earth. Unlike many stars scattered throughout our galaxy, Alpha Centauri represents a location that humanity could theoretically reach with future technologies. For decades, researchers in the United States and around the world have developed models and concepts for interstellar probes that might someday travel toward these nearby stars. Scientists from institutions including NASA and leading universities have emphasized that understanding Alpha Centauri is essential not only because of its proximity but because it offers a unique laboratory for studying planetary formation. The system itself contains three stars, each possessing different characteristics and environments. Alpha Centauri A resembles our Sun in many ways, while Alpha Centauri b is slightly smaller and cooler. Proxima Centauri, the dim red dwarf companion, presents an entirely different set of physical conditions. These differences allow researchers to compare how planets and atmospheres might evolve around various stellar types. With the arrival of Webb, astronomers gained the ability to observe infrared wavelengths with a level of sensitivity never before achieved. This capability allows them to study heat signatures, dust structures, and subtle interactions that previous observatories could barely detect. According to scientists, one of the most surprising lessons emerging from these observations is how interconnected and dynamic stellar systems truly are. Rather than existing as isolated objects, stars influence one another through gravity, radiation, and magnetic activity. Such interactions can shape the destinies of planets over billions of years. What may initially appear to be a peaceful and stable environment can, upon closer examination, reveal extraordinary complexity. That realization is both humbling and exciting. It reminds researchers that even the nearest stars hold mysteries capable of challenging assumptions that have persisted for generations. In many ways, Alpha Centauri serves as a reminder that a familiarity does not guarantee understanding and proximity does not necessarily translate into simplicity. When the James Webb Space Telescope launched into space, scientists describe it as one of the most ambitious observatories ever constructed. Decades of engineering, international cooperation, and technological innovation culminated in a machine designed to explore the cosmos with unprecedented precision. Unlike Hubble Space Telescope, which primarily observes visible and ultraviolet light, Webb specializes in infrared astronomy. This allows it to peer through clouds of dust and detect thermal signatures that reveal otherwise hidden structures. According to researchers, infrared observations provide critical information about the temperatures and composition of celestial objects. In the case of Alpha Centauri, these capabilities have opened entirely new windows into the nearby system. Webb's instrument can measure tiny variations in brightness and investigate the environment surrounding stars with extraordinary accuracy. Scientists are particularly interested in understanding the disks of dust and debris that may exist around these stars, since such structures can provide clues about the formation and evolution of planets. Even subtle patterns in infrared radiation can reveal information about collisions between asteroids, the presence of rocky material, and the effect of stellar winds. Researchers have explained that sensitivity of Webb is so remarkable that phenomena once hidden within background noise can now be examined in detail. Yet, with every improvement in technology comes a corresponding increase in complexity. Rather than simplifying our picture of our universe, better observations often reveal additional layers of uncertainty. This phenomena has occurred repeatedly throughout the history of astronomy. New telescopes do not merely confirm existing theories, they frequently expose unexpected features that require scientists to revise their understanding. In that sense, the James Webb Space Telescope continues a traditional stretching back to Galileo's first observations centuries ago. Each advancement brings humanity closer to the truth while simultaneously demonstrating how much remains unknown. For many astronomers, this process represents the greatest strength of science itself. Discovery is not about proving that we already possess all the answers. Instead, it is about accepting uncertainty and allowing evidence to guide our understanding. Webb's observations of Alpha Centauri are the part of ongoing journey. revealing a universe whose beauty and complexity continue to exceed expectations. In the end, perhaps the most disturbing discovery is not hidden somewhere among the stars of Alpha Centauri. Perhaps it is realization that the universe remains vastly more mysterious than humanity has ever imagined. The James Webb Space Telescope is providing glimpses into that mystery with extraordinary clarity. Yet, every observation reveals how much remains unknown. Scientists don't fear these unanswered questions, they embarrass them. Curiosity has always driven exploration, from the oceans crossed by ancient navigators to the spacecraft now studying distant galaxies. Alpha Centauri represents another chapter in that ongoing journey. Someday, future generations may send probes toward these nearby stars. They may uncover planets unlike anything we have imagined, or perhaps discover environments strangely similar to our own. Until then, the James Webb Space Telescope continues its quiet work, collecting photons that have traveled for years across the darkness of space. Those faint signals carry stories written long before humanity existed, waiting patiently to be understood. And as we rest beneath our own familiar sky, surrounded by the gentle glow of countless stars, we are reminded that wonder itself may be one of the greatest gifts science offers. The universe does not owe us simple answers, instead, it invites us to keep asking questions, and perhaps somewhere within that vast silence between the stars lies a deeper understanding of our place in the cosmos. Until that day arrives, we continue looking upward, guided by curiosity, humility, and the timeless desire to know what awaits beyond the horizon. Among the countless questions surrounding Alpha Centauri, none has captured public imagination more strongly than the possibility of habitable planets. Scientists have spent decades investigating the conditions necessary for life, recognizing that the presence of liquid water alone is insufficient to guarantee biological activity. Earth's own history demonstrates that habitability depends upon a delicate balance involving atmosphere, geology, magnetic field, and the behavior of the host star. In the Alpha Centauri system, these factors become especially intriguing because multiple stars create environments far more complicated than our own solar system. Researchers studying planetary dynamics have shown that gravitational interactions can influence orbits over long periods, potentially affecting climate stability. Meanwhile, stellar radiation and magnetic activity may shape atmospheric chemistry in profound ways. Proxima Centauri, despite hosting at least one known planet within its habitable zone, exhibits powerful flares capable of producing intense bursts of radiation. Such events raise questions regarding the ability of nearby planets to retain protective atmospheres. Scientists emphasize that habitability should be viewed as a spectrum rather than a simple yes or no category. Some worlds may possess conditions favorable for microbial life while remaining hostile to complex organisms. Others might experience long periods of stability, interrupted by catastrophic events. Webb's observations are helping researchers investigate these possibilities with increasing sophistication. By examining thermal signatures and atmospheric characteristics, atmosphere hope to gain insight into whether planets around nearby stars can sustain environments suitable for life. Yet, perhaps the most profound lesson emerging from these studies concerns Earth itself. The more researchers learn about other worlds, the more extraordinary our own planet appears. Earth's magnetic field shields life from harmful radiation, Its atmosphere regulates temperature and maintain essential chemical cycles. Plate tectonics recycle materials necessary for biological processes. Even the presence of a large moon contributes to long term stability. These interconnected factors create a remarkably favorable environment. Webb's investigations into Alpha Centauri remind humanity that the conditions supporting life may involve an intricate combination of circumstances developed over billions of years. Far from diminishing hope, this realization encourages deeper appreciation for fragile and precious world we call home. Thank you for joining me for another episode of Science to Sleep By. As you drift towards sleep, remember that somewhere out there, just beyond the reach of our eyes, the stars of Alpha Centauri continue their ancient dance, shining quietly across the darkness. And while the universe may still hold countless mysteries, perhaps there is comfort in knowing that discovery never truly ends. Good night, and until next time, keep looking up.